Cool. Uh, Now let's say that there are some more processes other than P1. Well, P2 was for about deallocation. Now let's say we are making some more processes. Um, and let's say that we make some two more process. Uh, let's say P3 and P4. Both of them they are asking for allocation of some memory, right? So they both will reach out to kernel and they will say, hey dude, can you allocate some memory for us, like size 2? Okay, and similarly, E4 will also reach out and he will say, hey dude, can you also allocate some memory for me? Some amount of size 3. Kernel will say, okay, I can do that, of course. And kernel will again go to the main memory and it will allocate those in the DRAM. Let's say here we have located this, you know, size 2, and we again allocate here size 3, size 3. Okay, cool. Well, now say that we are having P2. Okay, and let's say P2 asks uh P2 asks the kernel to deallocate uh size 1 and size 3. For example, it just said okay to deallocate both the sizes. Kernel says okay, I can do it, and kernel will then go to the main memory and just a second, yeah, and then it will deallocate both the memories. Okay, now this is an empty space. Let's for example, let's say that uh this this was 10 KB of space. Okay, and let's say that this was about 1 GB of space. 1 GB, right? Okay, now let's call for one last process, P5, and this says to kernel, let's use some different, and this says to kernel, hey dude, can you allocate 2 GB of memory for me? Kernel says okay, I can do that. Well, let me actually look if I can do it or not. Okay, so kernel will go to memory and it will start traversing from here. Okay, why here? Because this is the lowermost address, so this is like 0x0, and this is the uppermost address, it's like 0xf and so on, right? So it will start traversing from the bottom to up, and it will say okay, hey, I got 1 GB, that's good, right? Let me check if I can get another 1 GB in a contiguous manner. I'll come to this word in some time. It'll say, okay, well, I got 1 GB and now I've got 10 KB of space, which is allocated. So this 1 GB of space, it becomes, totally irrelevant because we actually need 2 GB in a contiguous manner. So it says, okay, no matter. I'll go here. I'll say, okay, here I'm getting 1 GB of space. Cool. What about, can I get more uh, traversing after it? But it cannot traverse after it because that's the upper limit. It says, okay, well, I cannot use that 1 GB also. And it says, the kernel says to, P5 that, you know, I'm really sorry. I'm not able to allocate the space that you asked for. But uh, we can actually see that it can actually allocate the space of 1 GB here and 1 GB here, and it will total out to be 2 GB. But it has to find the contiguous space only. Otherwise, it's of no use. Okay. Well, let's actually see why we need contiguous spaces, because that's more important now. Let me erase this CPU. Okay, and let's erase this too. Now let's say you have this int array 10. Okay, now what this will do is that it will first of all allocate some memory blocks, 10 memory blocks. Okay, so the whole length is 10, and each memory block is of size int. So integer takes 4 bytes, right? So this one block, it amounts for 4 bytes, and this whole 10 block, all these 10 blocks is 10 blocks, they account for 40 bytes of memory. Now thing is, okay, let's say that you want array of 0, which actually turns out to be the address of the array also, the starting address. Uh, this particular address, this is 0. Now uh, here you're going to have 1. Why? Okay, so now you say that you need array of 1. Well, uh, thing is that we have allocated those in a contiguous manner. Why? Because it's really helpful. How? Let's say that the starting address of array 0, it's like 2000, and now we want to access some array 3. What we will do, we cannot, like, now if all the all the memory blocks, they would have been allocated at different places, we would not be able to find array 3 at all. Then we would have to use linked list, but we are not using linked list here. So that's why we actually need it in a contiguous manner. Now what we can do is we can just do 2000 plus 3 into 4. Why 3 into 4? Because each memory block, it accounts for 4 bytes, and we need a third one. So we just add the 3 to 4, and we will see. Okay, so this is going to be 2004, this is going to be 2008, and there's going to be the third one. So 0, 1, 2, and third, this will account for the 2012, which is exactly same to this one, right? So that is why we actually need the whole memory in a contiguous manner, and that's why we cannot allocate 1 GB here and 1 GB here. But if we were to follow this contiguous manner, then it may happen at some time that we have a lot of space. This is our DRAM. Actually, we should say it as a main memory, not DRAM only. Then it may happen that suppose this space, it's allocated, right? This space is allocated, right? And let's say this space is allocated. Now we want a space that actually accounts for this space plus this space plus this space. So we would not be able to allocate it. And but we can still see that okay, there are more spaces which are totally empty and they are just useless, right? So we cannot actually follow this method of, you know, uh, allowing the process to directly talk to kernel, such that kernel will just allocate some space. We need more robust method, we need a better solution for that. And so what we come up with is something, we will see just in a moment. Let me just erase this thing. um okay,